start with integration by parts on this, and then you're going to see in this video a particular step that many of you are getting stuck on because there's a really cool trick that even I've missed. So for integration by parts, I'm choosing my u to be this entire natural log expression because it's very clear I can't just use a u substitution or a different choice of my u here. When I take the derivative of both sides, using the chain rule, the derivative of this outside function will look like this, and then multiplying it by the derivative of the inside function, you'll get 2x. And I'm going to just go ahead and rewrite this to be cleaner. And with integration by parts, we've found our u and du already, and now it's time to find what our dv and v are. So dv is whatever is left over that we haven't grouped as part of our u, right? It's just going to be dx. And then when you integrate both sides, you will get v is simply x. And so, as a refresher, you can skip forward if you already know this, but for integration by parts, it tells us the integral is going to be u times v, and then minus v times the integral of du. And now we just simply plug in what we know. We know that u is going to be this original natural log expression times your v. Your v here is simply going to be x. And then all of this is going to be subtracted by the same x times the integral of du. And we know that du here is just simply going to be what we found above. Your 2x all over 1 plus x squared dx. So the left side is easy. We just multiply the x, and we just get x natural log of 1 plus x squared. And on the right-hand side, after you multiply the x through into the integral, and you get the integral of 2x squared dx all over 1 plus x squared. Some of you might be getting stuck here, or you just don't want to have to deal with polynomial division or more complicated methods. Sometimes you have no choice, but here there's actually a trick you can use that you may have missed. I'm going to do the following. My goal is to imagine in my head and think forward a little bit about whether I can have this integral right here have something that looks like the denominator and that terms could cancel out, and that we're left over with something that has a lower power of x that's easier to integrate. So, do you see it? Tell me in the comments if you see it. Okay, so if you don't catch it, what you got to do is, let me go ahead and erase this. I'm going to just rewrite 2x squared as 2x squared plus 2 minus 2 dx, because this is going to actually allow us to group terms in such a way where something's going to cancel out. So you're going to get the original expression here on the left. Now here, what I want you to recognize is we have two different integrals going on, because remember, you can split this integral. The first one, we're going to allow it to be this part here, and for the second one, it's going to look like this part. Oops, that got erased. And so for the pink part, 2x squared plus 2, what I can do is I can actually factor out the 2 from the top, because then you'll get x squared plus 1, which is the same as the denominator, right? The only difference is the terms are just in a different order. And then the second integral is going to be really easy, because all you have now in the numerator is just this 2 dx. There's no x squared term that's going to give us a headache. So what's nice here is x squared plus 1 and 1 plus x squared are going to cancel out. So you're going to have x natural log of 1 plus x squared minus the integral of 2 dx. And then I'm going to factor out the 2 on this other integral. You can already do the integral in your head, I'm sure, for you ninjas out there. But if it helps, I like bringing out the constant, because now this should look like something you've already learned in your math class. That's just going to become an arctangent function, right? And so our final answer going to be this craziness.